Hey everyone. So after the last live stream, found out that the 134 message is maybe useful as the accelerator pedal. So just a quick recap on some of the Chrysler cars, particularly maybe 2018 gas-powered Jeeps and things. Occasionally, the current accel pedal 2 message gets sent even when the user is not pressing the gas pedal, maybe due to an ACC or something. So on the quest to try to find a better message for the user, the human actually pressing the gas pedal, that will not be triggered by ACC, and this way it will not disengage at low speeds. So we were looking some at cars that had these disengagements to try to find a better one. I think the 134 message looks pretty good. So now I'll take a look at a bunch of Cabana drives that you all sent in from chat in order to see if they're actually better, make sure they do not trigger on the hybrid ones, make sure the 134 does trigger when humans on hybrids do it, and hopefully if this works and if everyone stays asleep and I have enough time, then I'll go ahead and show you the rough process of how to do unit testing and send in pull request to OpenPilot, that sort of thing. Looks like even the dog is asleep and everything. All right, so let's pull up some of the drives that you all have sent over. All right, so here's the 2019 Pacifica Hybrid. Go ahead and pull this up. Go ahead and load the DVC. What we'll do here is I'll look for something where it looks like the user's accelerating, so I'll verify that ACC2 is not set to 7, which would mean ACC is engaged. Look for a time when the wheel speed is going up at a nice pace, and then I'll verify that the 134 message is actually being sent, showing up in the CAN bus that we can trigger on. All right, so it looks like it's sort of loading up here, kind of slowly. Hopefully Cabana is working well tonight. So I'll pull up ACC, although I'm sure at this low speed it's not actually being used. Sure enough, it's at 1. Maybe this whole drive is actually just sitting still, or maybe Cabana is being a little slow. All right, let's look at wheel speeds. Try to find a place where the user's accelerating. There we go. And then let's also look at the 134 message. Check chat, make sure you guys can hear me. All right, look at the 134 message, plot that out. So now let's look. The user is clearly accelerating around here. Let's see, sure enough, once it gets high enough, we're seeing some of this 134 activity here, which looks pretty good. It doesn't quite kick in at the very beginning of the wheel speed going up. But I guess they're probably idling. So at the low speed idling, it makes sense it wouldn't actually trigger. So this looks golden here. Now let's also look at a place where they're doing it after cruise control and make sure it's not triggering. So there it's 1, so it's not being used. Let's zoom ahead to some random time. This looks like a better candidate somewhere on the freeway. Let's see what that looks like. Getting any ACC messages as it loads up. Excuse me. All right, ACC status is 7, which means that it's engaged. Let's scroll up. Wheel speed doesn't really matter too much. And this nice accelerator 134 is a flat 0. Perfect. So this looks great. So we've analyzed this first one. So everything done after that. All right, let's go on to a cleverly named user lead poop, or is that lead poop? I don't know if either one's any better. This is a 2018 Pacifica Hybrid, so we'll take a look at this drive, assuming that it loads up. Speed test is pretty good. 100 up, 100 megs down. Just got Google Fiber using Google Wi-Fi, so I'm not actually using hard Ethernet, but Ethernet into the Google Wi-Fi repeater. So hopefully the stream's a little higher quality than before. Looks like this drive is not loading up too well. Let's go on to a different one from Billy Brunn. Here we go. Load up the DVC. And this one, the user said was a 2019 Pacifica Hybrid, similar to the one we looked at previously. Let's see if it'll load up. Take a look at the ACC. Sure it's not being used down there. Yep, and 1. Look at wheel speed to try to look for a place where the user is accelerating. All right, and then we'll pull up the 134. See what that's looking like. All right, so here we go. Look at a place. Here's a nice acceleration here. Oh, there. Let's highlight it and see. Sure enough, lots of 134 activity. Looks like we've used pretty much any value. The 134 seems like maybe at low accelerations, maybe that's from idling, it's not triggering, which is pretty much what we want. So now let's look for a place where ACC goes to 7. It goes there, but that's pretty short. Let's zoom ahead, see if there's a better place. This looks better on the freeway. Maybe we'll get some adaptive cruise control here. All right, no 134. We see ACC is in 7. We even see sometimes where adaptive cruise control is accelerating, although most of these sort of issues are reported at low speeds. So if we want to keep on looking, it'd be good to look at a low speed, but it looks like Cabana's a little slow tonight, not too bad. But flat on the 134, which is exactly what we want. Let's take a look at another car. So that was this one. And thank you for sharing all the drives. It makes it a lot easier, especially I don't have my Pacifica here with me. Taking this summer on paternity leave. This up here. All right, let's see. Find a place for ACC, just to make sure. Status, sure enough, it's just 1. Pull up wheel speed. And then we'll pull up the 134 message. All right, lots of noisiness here. And one thing I mentioned in the earlier stream is this accel 134, but in the structure we actually need to expand it from 4 bits up to something like 8 bits or maybe even higher, but that's not actually too important because the low bits should fluctuate enough. But I'll send a separate PR if we get a chance to make the size a little bigger. All right, let's just find any place with nice acceleration, which looks like there's a great one here. So I'll try to zoom in there if that works. Sometimes it's need to try a couple times. Nice accelerating path, and sure enough, for most of this acceleration, the 134 bit's being set. If you look at some other acceleration here, yeah, some activity on the 134. Message there. We set it. Now let's go find a place where maybe adaptive cruise control is being used to make sure that it's not sending that. Probably no ACC here. We'll see if something loads up. All right, yeah, ACC is still 1, so it's still sending the 134. So this drive does not appear to have ACC in it, so we cannot verify that it's not being sent, but I'm guessing it's not. We'll take a look. Yep, still 1, so ACC is not engaged. That's fine. So this was this drive, the 392, so that's done. No ACC. And now, what else do we have here? Mark in the beginning. Just this one that was not loading earlier. Let's see if it loads now. Looks like it's recent enough, July 15th, so not too long ago. There we go, it's looking a little bit better. Cruise control status, wheel speed, and then pull up the 134 status. All right, looks like the 134 is being sent whenever the wheel speed goes up. You can zoom in on this, which is great. It looks like, this is kind of interesting too. So one thing we notice here is that the adaptive cruise control kicks in right around 106.2. In fact, we can zoom in a little bit and get an even clearer view. I'll pause this so it's not moving. One thing to notice if we do right as the ACC kicks in right afterwards is that the accelerator pedal is still being pressed according to 134. So we might need a little bit of time so that you don't engage ACC, this 134 message gets sent, and then immediately disengages. That would be pretty frustrating. We'd have to do some actual experimentation to see whether the user is pressing on the gas at this time because the Chrysler is flexible with that, or whether this message is sort of sent for a while afterwards. But let's see what a rough time is. So this was happening at, kicking in at like 106.4. In fact, we can see, if we want to see the actual first message, we'll go over here, go over to ACC2, and then we can list it off here. We can go through and see when the status goes from 3 up to 7. They look like 104. There are a lot of messages. It doesn't matter too much. But maybe some other thing you'd want to know how to do this. So rather than one by one, I'll search, still at 3. Oh, 106, I'm looking at 104, that's why. So 106.4. Yeah, 7 units there. So we can see it approximately. So yeah, so this first one is 106.4. So I'll jot that number down here, as in this drive. So ACC turns on at 106.4. And now let's see when this accel message goes away, to try to find a reasonable sort of amount that we might allow the 134 to be sent, either right after ACC engages and OpenPilot turns on, or require it to be pushed for a certain amount of time. So we'll zoom in here and see when it stops being sent, right around 107.02. That's the last 134 message. So it looks like here we need like a second would be a good amount of time. So if we add some leeway and say, oh, you've engaged OpenPilot, less than a second ago, don't let the accelerated pedal, don't let this 134 message cancel it. Might be a good thing. And now let's also verify the rest of the time in this 7 that it's not sending it. So let's jump ahead to some random time and make sure that if adaptive cruise control is set to 7, meaning it's engaged, make sure that the 134 message is not being sent. Let it load up. This is a good test here. Oh, so yeah, it looks like no longer ACC, but this low speed. 134 is being sent. Whenever the speed goes up in that area, the speed's probably going up there too. So that looks about right. Go back so you can find some more cruise control over here. Yeah, 7 there, 0 there. So although the video is not playing, because I had paused, it's looking pretty good. Now the video paused, there we go. Yeah, so here it's at 7, meaning cruise control is engaged. And then here, the 134 message is not being sent, so that's perfect. All right, so this 134 message looks like what we want. And it's nice, it's already defined. We could define it a little bit better. But let's go in and see what the pull request looks like. All right, so here I am in my environment. Hopefully this is readable. If the font's too small, let me know if there's too much going on. Let me know. So here we go. I've already done the pipe-env shell. Finally fixed up my dependencies. Go into the Chrysler directory, run tests. And this is just a quick unit test to make sure we didn't mess anything up there. I'll go in there and let's edit the file that's being used for it now. Is it car state or interface? I always forget. I guess we'll find out. All right, car state is one being used, so we'll add in a signal here. So we're no longer going to be using accel pedal message here. Yeah, so that's what we'll be doing there. So just give a quick explanation of why we're no longer using it. And then I'll add in a new value here. I'm not sure if these are in any sort of order or anything. Now, the sort of interesting thing here is actually the message, and then the sub-message or whatever it's called, message and what do they even call it here? Signal, I guess. So the signal, the thing within a message. So here we actually specify the signal first, I believe. So it will be, it's named as accel_134. And then the actual message is just accel gas 134. And you'll notice later on in the code it's actually in a different order. So let's split the Emacs screen so we get a slightly better view of what's going on. And then now we'll go down to the accel here, and we'll switch this here where the order is different, the message and then the signal. It's a little confusing, but it's fine. A little inconsistency with the quotes. Accel 134. There we go. So now we've replaced it here. And now, what was that old one? We'll have to see if it's just checking if it's greater than 0 to see if we need to scale it or anything. It probably should be fine. All right, pedal gas. Oh, the other thing I should check, worrying about that delay, I was wondering if the old message is actually being sent during this sort of delay that we saw here. All right, so here we see the 7 going off, and then this 134 message starts, then the 7 kicks on, and then it goes down. So here we're not seeing that same sort of delay. So maybe the user was not even, we're seeing what's going on. Oh, it almost looks like OpenPilot was not picking up very many messages then on the ACC status. Like there's a little bit of lag where it's dropped some messages for some reason. So seeing some weird artifacts there. And if we go back to the beginning even, we'll look for that sort of delay and we'll compare it to the previous accelerator pedal message to see if we even have to deal with the delay. So while that's loading up, but I'll keep on coding here. We'll see how car gas and pedal gas are used to make sure we don't confuse any of the ints versus booleans and things like that. So this will underscore gas. All right, and now we'll look at the interface file, see how interface is using it. We just see gas press is just if the pedal gas, just defined over here. See if that is just greater than 0. That should be pretty adequate for what we're doing here. See how gas pressed is doing. If gas pressed and so we're checking here if gas is pressed and not gas previously, and you're going over 2 kilometers an hour or something like that because you press that in order to resume from stop and go, so we don't turn off OP. So it looks pretty good. Gas pressed, pedal gas greater than 0. Looks good. All right, so that should be all it is, assuming we don't need to do anything fancy to deal with the lag. All right, so as we saw here, let's see what's going on here. So here it goes up to 7. And then, this was sort of the interesting time frame, right, where we hit on ACC, but 134 is still being sent. So let's look at our old accel pedal messages, make sure we're not sort of regressing anything. Oh, what was that? Accel pedal message, accel pedal right here. So we actually have, let's turn off the wheel speed. We actually have pretty similar behavior here where this accel pedal message you're previously using is going up until 107. And it was fine, so this will keep the same behavior. Could make it a little bit more loose or something, but seems like no one's complaining so far. That's something you'd build in if you hit that where you turn on ECC and it immediately cancels or something. It looks like that must not have been going on here, so maybe there's some sort of delay built in somewhere else. All right, so it looks like the pull request should be good to go. So that's a super simple change. In fact, we might just want to go in car state and delete that thing that we're not even using. Delete this accel pedal message because there's no reason for it. Deleted code is the best kind of code. All right. you can see there, verifying that's the only place that it was being used. All right, so we didn't, now we also should go ahead and run the unit tests. Yeah, ran fine and everything. And while we're waiting, shouldn't matter for this, but I'll go ahead and also run the Docker tests. Well, maybe that'll slow down the computer. But normally I do something like, run Docker tests here, or sudo run Docker tests, or whatever I need to do. But that might lag the computer and mess up the stream. And this is a pretty low risk change outside of some of the Chrysler code, which is not really tested by the Docker tests because it's running the plant and Toyota or something like that. So we'll rely on the unit test here to make sure we didn't just mess up our Python syntax. All right, now let's get diff. All right, cool. So now we'll go ahead and go ahead and commit the change, add a change list, Chrysler change, accel pedal message to avoid false disengage on 2018 gas. All those speeds, and then all right, I guess we could even just go ahead and link to the analysis. So I could even just link to the YouTube video. How does this work? Get some sort of infinite loop here. If I link to the actual video, so I can link to this thing here and paste it in. All right, cool. Now, of course, we need to get push. What branch am I even on? All right, some random one I made up. And my upstream, all right, so I'll just get push up to origin, which is my own fork on GitHub. Push up to origin, and do I have to do like slash 060 test maybe? Nah, it's not a git repo. Yeah, so git push upstream, I have to do. No, I don't want to upstream, I want origin. 060 test, so but I use a space. Looks like. All right. Don't use git too much at my day job, but I've been using it for OpenPilot. All right, so now we can create a pull request. So I'll head on over first to my actual repo. Make sure everything looks good. All right, and I just pushed pull request here over on the 060 test branch. So I can go ahead and look at the commit that I made just to make sure it looks good. Make sure I didn't accidentally include some other files I edited. Sure enough, we have accel 134, accel gas 134. All looks quite good. The other thing that I'm interested to see, so these OpenDBC messages, definitions get imported into Python so they can be used. One thing that's fun to do with unit tests is to break your unit test just to make sure that you're actually testing anything useful. So I'll run the test, it passes. Now let's say that I broke this and I accidentally misspelled this. So I'll throw an X in the random spot there. Let's see if the test runs. Well, the test runs. So we're not actually testing too much here, which is unfortunate. So maybe we need to write slightly better unit tests that actually read in the definition from OpenDBC and actually use that and use car state. Because right now this run test is fairly weak. You can stay in Chrysler can test, which I think is just like the can crafting messages. Yeah, so it's not testing much. Maybe a lot of unit tests if I get a few extra minutes. All right. Now I'll compare and do a pull request. here, so that's one nice sentence. All right. And then who was complaining about some of these? Oh, and I should have double checked. Yeah, when I go in the comment eval from this. All right. Cool. I guess that's the end of the live stream for now. Or maybe we'll try to write a unit test. Yeah, it looks like she had a few minutes. Let's go ahead and see if I can figure out how to write an extra unit test for that'll actually work. So one thing, I can make all these changes here, and unless I actually do a git push, the changes will all be local and not actually sent up to my forks. They will not mess with the pull request. So what we want to do is test car state. So one easy way for just checking for Python syntax, trying to get can parser. So this is going to import can parser, all sorts of other stuff. So maybe I can even just start with the framework of the old Chrysler can test. Copy it over to carstate.py test. And then I will edit run tests so that it runs the can test and it runs car state test. And now car state test is just a copy, so it'll just basically run two sets of tests, which is fine. Let's edit car state test. Let's do some sort of real test here. Unit test, we'll leave that. Test Chrysler can, don't care about names too much right now. What we do want to do is do things like import car state. So even just the import is nice. Check for Python syntax errors. Figure out these tests. Let's do something simple like hopefully there's an assert true method. All right, we'll see if this still passes. All right, it's building all this stuff. Cool. Now the neat thing is the syntax thing. I wonder, yeah, so that means if we mess up our syntax here for whatever reason, like that, then hopefully this test will fail now. Yep, invalid syntax. All right, so we at least get some rudimentary testing there. All right, we'll change this to car state. Maybe we want to do like test get can parser. So CP. Oh, we need to pass in can parser. So we can try to see. How something else uses get can parser. And basically copy how they're doing it. So in car state test, of course that's me. Interface, how did they do get can parser? So now what are we going to do? So interface. So they pass in CP, which is passed in a car interface. That's not too helpful. Look for where is car interface. All right, so that's being called by something else. Yeah, so it's an object being knitted from somewhere else. I remember seeing this, but let's see where it's actually knitted from. me see where car interface is being called. So I'll go ahead and search the OpenPilot repo. Car interface, car helpers, car interface. This is just where it loads it up from different places. This is, oh, there's a test parser. So here they actually load up car interface. Good deal. So this would be a good thing to test. We'll use this test. Copy parts of other tests. Car interface, get params, not even car civic, and then get can signals it's calling. So maybe we want to see if we can use some of this. Here's get params. We pass in the candidate, fingerprint, and VIN into interface. But we still need to instantiate the object. No, I guess we don't. We just need to import it. We'll have to get this car import. And what value do we actually want? Let's just pretend to be this guy, because that's what I have. All right, let's see if this runs. Failed. All right, global, car seat, just a typo. All right. Hey, it works. All right, now let's see if we break, if we give it a bad name. In car state, if we're actually testing this get can parser at all, like let's see, we misspelled this with some X's. It still works. All right, so we're not actually doing enough to test it. By defining the signal, so we get can parser. And then where is it actually read in? We'll have to read in the car state object, which, let's see, it's being used. We'll read in from here, the pedal gas. Now what are we actually in? So we're in update, so we might have to call this update. That's gonna be a little bit of a pain. So now we wanna get some sort of CS object. Cat state, car state. And we'll wanna call in car state. To init it, we'll init it with, looks like CP. Where's that CP new? Attribute car fingerprint. That's what this thing is here. So that other place it didn't really matter. Yeah, fingerprint, candidate. Wait, car fingerprint. Maybe that's, Okay, so we want to pass in CP, not CP new. So I'm not so sure about that. All right. Now we want to call update, and this is update on the CS object, cs.update. Parameters are CP, so maybe that's CP new because we want to pass in the cam parser. CP cam. Let's see if it even cares about CP cam. It will. All right. Just one to get cam parser and get camera parser, right? Cool. So maybe this will work. Hey, that works. All right. Now let's see if it actually tests that we have the name right. Yeah, so that's exactly what we want. All right, so what we did here is wrote a unit test to make sure that if we got something wrong, that we might have actually gotten wrong in this pull request, that it actually had a test for it. So this unit tests are nice for just figuring it out. All right. Test and it works. Awesome. Now, let's see. All right, cool. Now let's see if there's any sort of style guide things that we need to do. Check code quality. Let's see if it yells at us. That's not soft F. It's not set as executable. PyFlake's not found. All right, well I guess I don't have it installed. I'll run that afterwards. It's included in the Docker tests, I think. Yeah, it'll run PyFlakes from inside Docker. I'll check that for errors later on. All right, so this looks good. So actually, I'll add this into the pull request. Add unit test for price the car state. All right, now I added a short unit test, which never hurts. I like unit tests just because they're super fast. So I have to actually super fast to catch bugs and things like that, rather than running all the Docker tests, which don't even test the set of code I'm really working on. All right, get push, not upstream, but actually origin, and then we'll do the 060 test. All right, and that should be good. Now if we go look in here, wherever my pull request was, something just beeped. All right, some Chrysler message. All right. So look here we go, 2 commits. All right, no conflicts with the base. And so by pushing to my branch, which I already have a pull request open for, it updates this. Let's make sure it looks good. Oh, run tests. But I forgot to actually add in the files. A good thing I checked here. So I don't actually have, if you look here, get diff, it's not actually showing this file that I wrote. So I need to do what? Git add car state test. So the Git actually starts tracking it. Now if we do a git diff, all right. All right, actually include the unit test. All right, sweet, and then I git push up. Cool, and that should be it. Now if we look here, it's actually included, just like we want. All right, see y'all later.